In today's laboratory, we're going to be looking at how different sized atoms form different sized molecules and how they interact with each other. What I have here is a representation of the periodic table, and as if you notice, on our periodic table up here would be hydrogen. We have the highly reactive, or what we called the party side in 6th grade class. Down here we have cesium. Now I didn't include francium because francium, there's some debate on exactly how big this atom is. But if you notice, we start here at the top, we go down, they get larger. But if we start here on the left side and go across, they actually get smaller. So why is that? Even though the atomic number is going up. We have 1 up here in this side, and the atomic number goes up to, what is it, 115 is the atomic number for one of the newer of the elements. So why is it that the atoms don't necessarily just keep getting larger the farther down the periodic table you go? Well, it has to do with the electrons in the outer shell. If you'll recall, there's a proton, a neutron, and then you have electrons flying around it. And as you go from this side, where there's less electrons in the outer shell, to this side where everybody's happy and stable, why they're called the noble gases, because they're all complete, well, as you become more complete, you actually shrink in size, even though you become more dense. So what's happening is, while you don't have those wild and woolly electrons just flying everywhere trying to kidnap another electron to make them stable, you can actually get smaller in space. Well, today we're going to be talking about 3 different atoms that we're going to be putting together into different shapes and configurations. First, we're going to be doing hydrogen. Now remember, hydrogen by itself is 1 proton and 1 electron. Yes, there is the version that has 1 proton, 1 neutron, and 1 electron. But for most of us, it's 1 proton and 1 electron. That's how we see hydrogen. Then we have oxygen. Oxygen is 8 protons, 8 neutrons, and 8 electrons. It's too shy of being perfect on that outer shell, but it'll hang in there, and it likes to react with a few things, but it's a fairly stable kind of guy. It's the kind of friend you like to have around. Then we have carbon, which is the basis of all life on Earth. 6 protons, 6 neutrons. It's got 2 in that inner shell, which makes that perfect, and it's got 4 in the outer shell. Carbon, it likes to hang out with everybody. So we find carbon in a lot of different elements and molecules out there. So down here, if you look at this, we have a water molecule. That's the oxygen and 2 hydrogens. We've got hydrogen in orange, oxygen in blue, and the carbon in purple. Well, today we're going to be playing with water and isopropyl alcohol. Now, what I've done here is kind of tried to draw the molecules as they might be represented in real life. Water is kind of a dense molecule. It's got the 2 hydrogens up close to the oxygen. But then we have isopropyl alcohol, 3 carbons, an oxygen, and 8 hydrogens. And these guys take up physically more space in the universe than does our water molecule. So we're going to do some math, and I know I just said the M word, that 4-letter word that all of you love. We're going to go over here to the experiment station that I've set up for us. Let me set you down and get you organized here. What we're going to be doing is we're going to be looking at how math affects our experiments and how we have to take into account the different sizes of the different elements. And so let me get this turned a little bit here where it lines up a little more evenly. There we go. So what I've got here is I have 3 graduated cylinders. I think we can see that. 3 graduated cylinders. 1, 2, 3. 1, 2, 3. And in these graduated cylinders, I think you can see this on the camera there, I have them filled. These are 50 milliliter. Let me show this to you so you can see this. This is a 50 milliliter, it says 50 right there at the top, 50 milliliter graduated cylinder. And I have each one of these graduated cylinders filled to 25 milliliters of water. Let me see if you can see that. Yeah, there's 20 at the bottom, 30 the next one up, so it's right at that bottom of the curve is at 25. So these are filled with 25 milliliters of water each. Now here's the thing. When we have like molecules, in this case, water and water, 25 plus 25 is going to equal 50. I think we all know what 25 and 25 equals. But what happens when I take water and some other kind of liquid and try and mix them together? Well, we'll get to that in just a second. First thing I'm going to do, though, is let me move this up here in front. Let me turn him just a little bit. We're looking for this line right here. First off, let's just prove that 25 and 25 does equal 50. Here comes 25. Get that last drop in there. Very good. Here comes 25 more. And, oh, I think we did it. I think we have success. Let's take a look here. 25 and 25 does in fact equal 50 when we're talking about water. But what happens if we want to mix this with something else? Let me go ahead and take care of this here. We're going to put 25 milliliters back into this graduated cylinder so that we'll leave 25 in the other one. Okay, just be patient with me here a second. We're going to put this back because we may come back and use this in a moment. And let me check. Just about 2 more drops. Can he do it? Is he spectacular? And he's not, because he just over poured it. Dadgummit. Let's go back here. You guys are so patient with me, I tell you. Thank you for watching. But this is how it would work in class too. 25 and 25, and we've got it as close as we can get it. So there we are, back to 25 and 25. So I'm going to use this one here. I'm going to be adding isopropyl alcohol. This is 91% isopropyl alcohol. And I'm going to pour 25 milliliters of isopropyl alcohol. Now remember, isopropyl alcohol is a larger molecule. Pour back just a little bit. Make sure I've got 25. Ooh, so close. 2 more drops. Here we go. Come on, get a wave. Get a wave. There we go. And, oh yes. All right, so here we go. 25, I think you can see that. There's 30 on top, 20 on the bottom. We're right in the middle. 25 milliliters of isopropyl alcohol. All right, so we just proved with water that 25 plus 25 does in fact equal 50. But what happens, and these are both clear, I think you can see that. Yep. But water is a denser molecule. So there's actually more water molecules sitting in there. But the alcohol molecules take up a little bit more space in the universe. But they still look clear and they look like liquids. But what happens if I pour them together? Let me move him out of the way in the back. Well, here's what's going to happen. 25 and 25 is supposed to be 50. So let's find out. And let me put my funnel back in there. 25 and 25 is supposed to be 50. 25 and 25 is supposed to be 50. 25 and 25 is 50, right? Okay. What do we have here? 25 and 25 equals 25 and 25 equals 48 and a half. What? 25 and 25 equals 48 and a half. Now you look at the bubbles. See those bubbles that are forming inside the graduated cylinder? That is coming from the reaction of the water and the isopropyl alcohol. The water and the isopropyl alcohol are swapping electrons right now as we speak. They are having molecular playtime in there, and they are giving off gas bubbles. Or actually, it's not even gas bubbles. It's just space bubbles. So even now we started at 48.5, but our number's actually going down as we create more space in there. Kind of mind-blowing. 25 plus 25 equals 48 now. Yeah, look at that. Can you see that? 25 and 25 equals 48. We've actually created a half a milliliter of space just in the time that we've been doing this. So, how does this work? Well, let's go over here and take a look. What I have here is I have my handy dandy test tube set out, and I have some colored water in this one. This is just plain old distilled water. And I have an empty test tube here, and I'm going to fill this empty test tube about halfway with the colored water. And I think you're going to like this because we're going to see something happen here. So we're going to fill it about halfway. And then I've got my isopropyl alcohol again. And open up. Let's see if we can just pour this in here. We may not even have to use that other one. So I pour this in here, if I do this right, and didn't work. Started making space. Well, let's go with the rest of this then. Watch what's going to happen here. I'm going to create space magically. I'm going to go ahead and put a stopper in this. You can see the fluid falling over the top of it. And I'm going to shake these together now. Shake these together. And guess what? Here's a bubble in the top. It's forming. We are creating space out of nothing. Space out of nothing. And if you feel the test tube, it is getting a little on the warm side. That's what we call an exothermic reaction. Let me get the camera here. We can zoom in. You can see the bubbles forming. We are creating space in the top of this test tube. As we look down there, there's a bubble forming in the top. Where's that bubble coming from? I didn't have any air captured in there because when I put the cork in, you saw the fluid fall over the top of it. So where's the space coming from? It's coming from the atoms mixing together and actually creating the space. Because as they come together, that liquid occupies less volume, takes up less space in the universe. So this bubble, it's not a gas. There's no pressure in here. This bubble that's in here, there you go, see that bubble? This bubble is just a vacuum. It's just a spot where there is no space. There's nothing there. There's no gas. I've created it magically with the chemical reaction of the alcohol and the water. And if I take this off, you should be able, it went, so it actually sucked air in. So amazing. Alcohol and water.